Okay, the oil as well. I got this set up all completed with the batteries, working quite well. Got my renogy meter, is working very well. It's a smart battery one. I definitely recommend getting one of these. It's a pretty nice company, Renogy. They make some nice stuff. I ordered a charge controller too of theirs. They're a new American company. They started up in the renewable energy technology. They're Chinese stuff, but they're actually well researched and developed technology. It's not crap, but it's not high end either. It's pretty good stuff for the price. They're also assembled in China, made in China. Yeah, I guess it's made in China there. But it's for what this stuff actually is for the price, it's pretty decent stuff. I've had a good start to get a menu. I've set the parameters up. Basically, you program you have whichever battery power or battery bank you have. See here, 10 to 120 volts DC. Any battery bank configuration, this thing's compatible with. In this case, I got banked up my 6-volt batteries into 1, 2, and 3 banks, 3 12-volt batteries, and added those capacities together, which calculates to about 500 amp hours. I just programmed that into here. 497 amp hours I got left out of 500. 99 hours and 59 minutes. This clock's it's not 100% accurate, because if I'm pulling a 10 amp load off this inverter, that's going to pull about roughly 200 amps, 250 amps, 2.4 kilowatts. There's a bit of you gotta lower Pukett's law and stuff like that with batteries. Higher discharge rate, the amp hours won't be quite what it says in the label. In this case, 240 amp hour at 20 hours, or 195 amp hour at 5 hours. I'll do a test on this, boil some kettles and see how long these last. I did a quick off-camera test. I ran these two vacuum cleaners, 1000 watt and a 1400 watt. Together they pulled 2.4 kilowatts, 10 amps. And this thing was showing 9 amps draw. It was pulling 9 amps altogether. Because there's initial startup current, but as the motors warm up a little bit, the power drops. But if I block the outlets, they use less power, because the motors are getting air, no resistance. So the motors will pull less power. But initially they did pull 10 amps out of this inverter, and they did it with ease. The voltage dropped to from full 30.4, dropped to about 11.2, 11.1, and stayed there the whole time I had these two running. And this is waking up because I put a load on it. I turn this on. On standby, the inverter is pulling 0.4 amp. 13.2, he's just showing 30.3. But basically how this hooks up, you've got this 4 meters of long cable, which is really convenient for, makes it really universal. The big 500 amp shot, your positive goes this, or in this case negative, this goes in your negative, this one. Your positive, this runs your meter. It feeds positive through here to run this little panel meter. I've got my shunt hooked up on a negative there, and that goes to the inverter. And there we are. 5 watts. Putting 5 watts. Not bad. I've my solar panels I've scored. Got them on the roof. I've got to hook up to this Muppet charge controller. Modified it so it doesn't get too hot, because a little 1mm thick steel plate is all I had for a heatsink for 3 MOSFETs. They were lighting that pissy little bit of metal for a heatsink, but that just wasn't good enough. I did test this thing on the other solar panels on my Misto inverter. This thing got too hot. So I've added this quite thick 8mm thick aluminium slab, aluminium plate, and bolted onto this heatsink. And that's much better. That's going to last. because it's only rated for 500 watts. I'm putting a kilowatt worth of solar panel through this thing. Having this heatsink is well worth it. And it's cooking this full river battery, which is an empty river. It's a dry creek bed. It's not charging. It's bloody hot though. Whew, that's hot. That's hot. Sad, yeah, it's sad battery. Yeah. As for this can also work at any battery, lithium iron phosphate as well. This meter. The charger, solar charge controller for Renogy I got coming, also has multiple battery types. But I've only got this on test. My solar panels are up here. I've only got them on test at the moment. I've ordered some 3-way Y branch connectors. I'm going to hook those all up together through my 3-way Y branch connectors, and those 3 panels are hooked up properly in parallel. And then those 2 connectors are going to go from there, the main negative and the main positive. But I got some more of this cable. I've got another 5 meter, a 5 meter extension set coming as well. And these are going on my charge controller. I'm going to plug into the ends of those 5 meter cables. And I'm going to set up my final setup is going to be on the wall right here. Make up a little thing on the wall, bolt the charge controller there, run the wires through there from the solar panels to here. Everything's going to be here. Make up a little panel to mount this on, and make up a little cabinet to put over these batteries. Just so my little one doesn't go shorting these out. Be a hell of a experience for him if it shorts those out. You need 1000 amps of short circuit current per battery. I've twisted these cables a little bit so I can see my little things. Yeah, these aren't going to be cycled very hard. Doing something like this these batteries will last for ages. But as long as this has got power drawing through it, it lights up. Doesn't draw much, 0.4 amps on standby. If I turn this off, 0.01. There's not really much drawing on that, other than probably what this. It's probably measuring what this meter itself is drawing. That's to be expected. I turn the inverter back on. It's got a sense it's getting power drawn through it. It wakes back up. You can see the arrows are going down. I'm draining it. I'm draining the battery. But yeah, it's pretty straightforward. You read the book. You said you calibrate your amp hours into here, and you set the correct battery top. In this case, lead acid. I've set up my capacity, and this calculates it itself. Once you set that, it'll calibrate that to 100%. 99 hours 59 minutes. But as I said, that's not going to be 100% accurate, that clock, that timer, because that varies for certain loads. Your amp hours is all going to vary. Light loads, you're going to get more your full rate of amp hours out of your batteries. Heavier loads, it's going to be less. Although it says 240 amp hour, doesn't necessarily mean you can pull 240 amps out of the battery and it's going to provide that power for an hour. It doesn't quite work that way. Now next, I've got to clean up this electrolyte off the top of the batteries. I've got to get me a little rag with some bicarb, a damp cloth, and just clean these up. And my little one did fiddle around here and touched it, had to wash his hands. I'm quite happy with this. It's good. It's very handy to have these sorts of batteries. As I said, these came out of a Tenant 36-volt floor sweeper. Typically this will probably last about 30 minutes of floor sweeping, and these batteries will be completely flat. That sort of machinery does run these things down hard. Scissor lifts too. They pull about 50 or 60 amps to run the hydraulics. Typically you get about, for scissor lifts being used heavily in an 8-hour shift, the batteries would last that whole shift, it'd be flat. But what I'm doing here, at the moment, these are going to last for ages. But I'm very happy with how this has all worked out. It says loads on. I can turn that off. Oh, hang on. I've got nothing plugged into it. And it smells good. Charging my phone with the inverter. Yeah, putting a bit of colour there. That's just using that to charge my phone. 1 amp charge. That's a 2.1 amp charge. Go onto my phone. I'm actually pulling that there because my phone's obviously not going to pull that much. It's not that flat. I've got that USB port. I've got USB ports on this charge controller. Anyway, let's go set some loads up. Let's let's set this little problem up, for example, and do a test. And we'll have a look at the consumption on the battery side of the inverter, what the problem was that it consumed. The problem was just turned on, 85 amps and dropping as the resistance drops as the heating elements heat up, pulling in kilowatt, 22 hours and 47 minutes, but it's varying. It's dropping the amps as the heating element resistance changes as they warm up. 12.5 volt. Yeah, it's 12.3. This gets to about 42 degrees and the fans start to come on. 4.1 amps it says I'm pulling here. That's off the mains 240 volt side. 240 volts, 239. Stays stable, so the voltage is alright. I'll touch this. Barely warm. Shouldn't be warm anyway because it's a 500 amp rated shut. That's alright. I've actually got 6 hours of runtime. I can cook pies with it in the power outage. I can cook pies in the power outage. How good's that? Let's get a heater out. Well, that's running. I'll get the heater. It runs those lights good too. That's a 2 kilowatt load, those lights. I'll be able to try those next. Oops, untangle this cord. That's off. We'll set that away. It's quite warm today. I don't want to get too hot. Okay. Plug that in. Turn this on. There we go. Oh yeah. 153 amps. There we go. 4 hours and 14 minutes. Basically there, it's going down, 493 amp hour. 1.8 kilowatts of the DC side, 7.2 amps. That's 800 watts plus this load, which is a what's this one? I forgot what it is. I didn't take any notice. 1 kilowatt. That's 1800 watts load. Turn that off. That's a 1 kilowatt polymer. I get my 2 kilowatt lights and run my 2 kilowatt halogen lights with that polymer, which is obviously going to overload the inverter because it's only a 2.5 kilowatt and not a 3 kilowatt inverter. But the kilowatts dropped a little bit because this thing's warmed up. So we'll see if how it handles these lights with this polymer. Let's plug it in. There we go. Oh, 11.1 amp, 10.9. Didn't like that. He didn't like that at all. Yeah, that's to be expected. It won't run 2.5 kilowatt all day. I heard 2.3 and 2.4 kilowatt for these two inverters, sorry, vacuum cleaners. And ran that for a little bit. Well, here we go. 138, 170, 200 amps. 2.7 kilowatt, yeah, 240 amps. Yeah, it's quite to be expected. Get to 2400 watts, 2400 watts of 340 volt output. It was pulling 250 amps on the DC side. That's to be expected. Well, I fill my battery connections here for any hotspots. Normally an FLIR camera would be handy for this. No hotspots. No, that's good. My connections are good. No hot spots at all. Look at that. Awesome. That's fully heated up. Nice. That's gotten nice and hot. Toasty. 37 degrees Celsius. Nice. Now just plug the lights in alone. 8.2 amps. 2 kilowatt load, 166 amps. So I've run that for about half an hour. There is a formula to calculate the accuracy of that, but I believe it. As I said, there's variations. This is not exactly accurate because it varies. As I said, it varies with loads, light loads and small loads. Even more accurate with smaller loads. So I'm quite happy with that. Still smell of Chinese and burning off the inverter as I'm breaking it in. Anyway, I'm quite happy with that. I'm only charging my phone. The sun's going to do the rest. And charge that back up. Anyway, thanks for watching.